For 10,000 years, one material decided how far humans could build. Wood gave us houses, ships, bridges, entire cities. But wood has a limit built into it. A tree strong enough to hold up a roof takes decades to grow. And right now, in 2026, China has quietly stopped waiting on trees. Engineers there are raising apartment blocks and vehicle-rated bridges out of something that regrows completely in under 10 years. Something so ordinary that for 100 years, nobody in the construction world took it seriously. It bends instead of snapping. It pulls carbon out of the sky instead of putting it in, and it is already strong enough to carry a fully loaded truck across a river. This is not a lab prototype. This is happening today, at national scale, backed by government money and real buildings you could walk into right now. By the time this video ends, you will understand exactly how a plant that engineers used to laugh at became one of the most important construction materials on the planet. If you're finding this interesting so far, drop a like. It genuinely helps this channel reach more people. And subscribe, because what we're about to get into gets a lot stranger before it gets impressive. Let's get into it. The trap builders were stuck in every material humans build with comes with a trade-off. Wood is renewable, but painfully slow. A construction-grade tree can take 25 to 75 years to mature. Plant one today, and your grandchildren might be the ones who get to use it. Steel and concrete solve the speed problem. You can pour a foundation and raise a tower in months, not generations. But that speed has a cost nobody put on the invoice. Steel and concrete production together account for more than 15% of all global carbon emissions every single year. Every ton poured is a ton of carbon released. So for decades, the construction industry was stuck choosing between two bad options: slow and clean, or fast and dirty. Nobody had found a material that could do both, until engineers in China looked again at a plant that had been growing in backyards and forests for millions of years, and asked a question nobody had seriously asked before. What if we stopped treating it like a novelty? The plant nobody respected. That plant is bamboo. And here's the detail most people get wrong. Bamboo isn't a tree, it's a grass. The same family as the lawn outside your house, just scaled up to absurd proportions. On paper, it sounds almost fictional. Bamboo is the fastest growing plant on Earth. Certain species can grow over a meter in a single day. Fast enough that, if you sat and watched closely, you could actually see it move. While a tree spends decades reaching usable strength, bamboo gets there in 6 to 9 years. And because it's a grass, cutting it down doesn't kill it. The root system stays alive underground, and a new stalk simply grows back. No replanting, no barren hillsides, no waiting years for the land to recover. Then there's the strength. Pound for pound, bamboo can be pulled and stretched with more resistance than steel, and its raw strength is more than double that of standard wood. This isn't a new discovery. People across Asia have known it for thousands of years, using bamboo for scaffolding, bridges, and homes, long before modern engineering existed. Even today, construction crews in some cities still climb bamboo scaffolding, dozens of stories high, trusting their lives to it every day. So if bamboo is this fast, this strong, and this renewable, why didn't the modern construction industry adopt it decades ago? The answer is a list of very real, very frustrating flaws. And it's the reason bamboo spent a century being treated as a joke. Why engineers rejected it for 100 years. A raw bamboo stalk is a nightmare to build with, no matter how strong it sounds in theory. First, it's hollow, which makes solid connections nearly impossible. Second, it's round, and modern construction is built around flat, square beams. Third, and this is the real killer, its strength isn't consistent. One stalk from a single plant can be remarkably strong, while the one right next to it is weak and unpredictable. Drill a bolt through it, and it tends to split straight down the grain. Leave it untreated, and it rots fast, attracting insects looking for an easy meal. Now think about how buildings actually get approved. An inspector can't sign off on a beam because it seems strong enough. Structural materials need to perform identically every single time. In freezing winters, brutal summers, and 30 years down the line. Wild, untreated bamboo could never make that promise. Because of that, the engineering world gave it a nickname that stuck for nearly 100 years. The poor man's timber. Good enough for a hut, never good enough for a real city. For a long time, that was the end of the story. Bamboo was filed away as a backyard material and forgotten by anyone doing serious structural work. But the breakthrough that changed everything wasn't a smarter species of bamboo. It was a complete change in how people thought about the material itself, and it came from a place most people would never expect, turning a plant into a product. Here's the question that flipped the entire industry on its head. What if, instead of cutting bamboo into boards like wood, you treated it more like raw flour before it becomes bread? That idea led to something called bamboo scrimber, and the process is honestly strange to picture. It starts with a whole bamboo stalk. Instead of slicing it into planks, machines crush and tear it apart along its natural grain. An industry term for this is fiberizing. What comes out doesn't resemble lumber at all. It looks like a loose, stringy pile, almost like rough straw. And here's the brilliant part. Every one of bamboo's original weaknesses, the hollow center, the round shape, the splitting, the inconsistency, simply disappears. Why? Because the original stalk no longer exists in any recognizable form. It's been completely broken down into raw fiber. From there, workers dry the fibers and soak them in a resin so everything binds together. Then the fibers get aligned in the same direction and pressed, not gently, but under extreme pressure and heat, forcing out almost all the trapped air. What comes out the other side is dense enough to sink in water, with a hardness that beats most hardwoods sold today. A wildly inconsistent plant has been transformed into a uniform, dependable, manufactured material. And the process wastes almost nothing. Roughly 80% of the original bamboo stalk gets used, including the bent, low-grade sections that would normally be discarded. The numbers here are hard to believe. High-quality bamboo scrimber has tested with compressive strength above 160 megapascals, and bending strength past 300. This is a grass that fully regrows in under a decade, now performing like premium engineered hardwood. And here's something that will surprise you. This isn't some brand new invention. The first high-strength version of this material was created in China back in 1987 at Nanjing Forestry University. The science has been quietly improving for almost 40 years. What changed recently wasn't the chemistry, it was the ambition to actually deploy it at national scale. And that meant clearing a hurdle that had nothing to do with chemistry at all. The real obstacle was never science. A powerful material sitting in a university lab doesn't change the world by itself. Plenty of brilliant inventions never make it past the testing stage. The real gatekeeper deciding whether a material becomes a global industry is something that sounds boring, but matters enormously. The building code. Codes move slowly on purpose. Getting a structural material wrong isn't just a financial mistake, it's a building staying standing mistake. An engineer can't put an untested material into a hospital or a school, because one study says it seems promising. There need to be years of testing, agreed international standards, and a paper trail any inspector anywhere can verify. For most of bamboo's history, that kind of proof simply didn't exist. Even today, there's still a gap. When researchers studied companies producing structural bamboo products globally, only about a third published clear data on their material's actual strength, and even fewer held basic environmental certifications. If you're an architect considering this material for a real project, that missing information is a serious problem. You can't build something important on numbers nobody is willing to show you. But that gap has been closing fast. Engineered bamboo is now being tested against the same international standards used for structural timber, and research has exploded. Nearly 7,000 studies on engineered bamboo were published in the 10 years leading up to 2024. Every study is another piece of evidence inspectors need before they'll approve it. Slowly, bamboo stopped being an interesting curiosity and became something engineers could confidently put on official paperwork. And once that confidence arrived, people stopped using bamboo for flooring and decking. They started building things with it that no inspector would have approved just 10 years earlier. towers, bridges, and real weight. For a long time, the joke about bamboo structures was that they were fine as long as they stayed 1 story tall in a warm climate. A garden pavilion, a footbridge, maybe a cozy eco-resort cabin. Cute, but not serious engineering. Then everything changed. In China, engineers designed and built what is now recognized as the world's first 7-story building, constructed mainly from engineered bamboo. Not a building with decorative bamboo paneling, a real multi-story structure where the columns, beams, and floors were built from prefabricated engineered bamboo. 7 full stories, made from a plant the construction world had dismissed as a hut material 1 generation earlier. It didn't stop at buildings. Bridges made from the same engineered material have been built strong enough to carry actual vehicles. One bridge, assembled from prefabricated bamboo sections, was built by a small team of workers in about a week, without any heavy construction equipment. A bridge made from grass, strong enough for a truck to drive across. This is the part that genuinely shocks people inside the construction industry. Engineered bamboo isn't a cute sustainability side project anymore. It's doing the job that used to belong exclusively to steel and concrete, carrying real weight, in real buildings, that real people walk into every day. And once a material can do that, a much bigger question naturally follows. Not can this work, but how far can this actually go? Because the country behind this breakthrough isn't treating it like an experiment. They're treating it like national policy. And the scale of that plan is bigger than most people realize. A national plan, not a side project. In 2022, China partnered with the International Bamboo and Rattan Organization to launch a global initiative under a simple, bold name, bamboo, as a substitute for plastic. Chinese leadership backed it publicly and tied it directly to the country's climate goals. The following year, a 3-year national plan rolled out to scale bamboo as a genuine replacement for high-emission materials like steel and concrete, complete with demonstration zones built specifically to prove the industry could function at massive scale. This is the difference between a cool material and an actual movement. China holds roughly 1/5 of the entire world's bamboo supply, and it has built an industrial chain to process it from forest to factory to finished structural beam. According to the country's own figures, its bamboo forests absorb and store around 300 million tons of carbon every year simply by growing. There's serious money behind this too. China's bamboo industry is targeting a value of 700 billion yuan by 2025 and a full trillion yuan by 2035. When a government puts numbers that large on the table, the rest of the world starts paying attention and starts competing. When researchers mapped companies producing structural bamboo worldwide, roughly 2 out of every 3 were based in China. But new players are emerging in the United States, India, Indonesia, Vietnam, and Singapore. Even South America, home to its own giant bamboo species, is beginning to see it as a genuine export opportunity. The technology China refined is spreading outward the way every real industry eventually does. What's driving this growth isn't sentimentality about plants. It comes down to practical math. For a builder facing new carbon taxes and tightening environmental regulations, a material that regrows in under 10 years and locks carbon inside a building instead of releasing it isn't a nice idea. It's a competitive advantage. No serious construction company can afford to ignore that advantage for long. The honest catch. Before this turns into an uncomplicated success story, it deserves an honest look at its limits. That dense, impressive bamboo scrimmer is held together using resin, often a phenolic type. That resin gives the material its strength and water resistance, but it also means the finished beam isn't purely natural anymore. It's a composite. Questions about fire performance, decades-long durability, and what happens to that resin once a building is eventually demolished are still being studied carefully. There's also a real infrastructure challenge. Turning raw bamboo into certified structural beams requires factories, fiber processing machinery, resin baths, and heavy hydraulic presses. China built this entire industrial chain over decades. A country with plenty of wild bamboo but no industrial base can't simply flip a switch and start producing certified building beams overnight. The places that could benefit most from a cheap, fast-growing structural material are often the furthest from the equipment needed to actually manufacture it. Closing that gap isn't a science problem anymore. It's an investment problem, a training problem, and a policy problem. And as covered earlier, building codes move slowly on purpose, because safety always comes first. None of this erases what the science has already proven. It simply marks the distance between what's possible today and what still has to be built out across the rest of the world. And based on everything happening right now, that distance is closing faster than most people in the industry expected. The bigger picture engineers took a plant the construction world dismissed as material for huts. They stopped trying to use it like ordinary timber, crushed it down into raw fiber, and pressed it back together into something stronger than the hardwood it's now replacing. It regrows in under 10 years without needing to be replanted. It locks carbon away instead of releasing it, and right now, it's already holding up 7-story buildings and carrying trucks safely across rivers. For thousands of years, building bigger meant cutting down something that took an entire lifetime to grow back. For the first time, there's a serious structural material that fully regrows before a child even finishes school. That is genuinely new and genuinely worth paying attention to. If this changed the way you think about the next building you walk into, hit like. It really helps this channel keep making videos like this. Subscribe and turn on notifications so you don't miss the next one. And here's a question for the comments. If a plant that experts mocked for 100 years turned out to be this powerful, what else do you think we might be overlooking right in front of us?